Hey, I'm Daniel Gavriolik, lead ZA Content Pipeline Manager and Level Designer.
Hi guys, I'm Sam Claussens, aka Gears AD, and I'm responsible for the engine development and project management of Z-Test Area. So for the first article on development of Z-Test Area, we're going to give you an overview of the menu system and how it was built, with links to all the components and bits and pieces so that you can use the same concepts for your own ideas and games.
So I joined the team a little bit late. Why don't you talk us through the old menu system, Sam?
So the original menu system was really clunky and static, kind of like the old Doom menu system with 4 or 5 options. Although a little worse. And it's something we really did strap on at the last minute just for Dream Build play. It was very separate from the original game environment, and you could see where, as soon as you exited the menu system, it was a whole separate atomic component. And there was no suspension of disbelief. You knew that you were in the menu system or you were in the game, and the two did not overlap whatsoever. So here come Dan and the other content guys, joining up a little bit after the first Dream Build play entry. And they began poking holes in all the stuff we thought was looking really, really good. That is, all of the content. I mean, from our side, from developers, we were like, sure, this looks fantastic. It's, a texture at the right place. Good origin, let's work with it. But, of course, we're visually challenged. So they poked a lot of holes in things. And specifically, Daniel began mauling what we thought was our fantastic two-option, new game or exit menu system, saying it really wasn't up to spec with the rest of the game. For example, we got this big 3D textured blended terrain and this horrible menu system with a bit of video and, a little up and down cursor. So we made the big mistake of asking him to give us an idea of what he thought or what he thought a player would like to see from the game.
So my initial comment was, you guys should show off the game engine. Secondly, you should visually link the actual game to the menu system. So here is what you control in Z-Test Area, the tactical satellite. So literally, from the start of the game, players are involved in the game. Thirdly, the menu system should feel seamless, from the actual ship that transports the players to the station, right up to the point where the player starts playing.
Without a single sharp change between the menu and the game to knock you out the feeling that you're inside this game world, which we really liked, because it makes it a seamless environment.
So us content guys went ahead and created some concept images of what we wanted to see in the menu system. We then went ahead and we modeled out the entire menu system.
So we really had two options to build this new environment. And the first was we could take the content guys movies and literally strap them together in the order as you move through the menu system. But I don't know, as a group of developers, we thought that really would just feel like someone just sellotaped a bunch of movies together, and it didn't have the same feel to it. You would just pick up on that this was a bunch of movies, and we wanted something more of a demonstration of what the engine can do. And so we thought, well, instead of doing this movie sequence, let's build this dynamic environment for real, with real to scale astronomical units and a proper camera and a real dynamic system that we could actually fly around in. And one of the fundamental components in this is how the camera moves. It isn't according to splines, because that doesn't feel quite right. It actually uses a set of control systems. And the first topic that we're going to quickly look at here is the mathematical equations to do exactly that. So here's just a quick overview on how to do smoothish dynamic camera motion, but very easily. And the problem statement is you've got a camera sitting at C1 in 3 space, and you've got a target sitting at T1 in 3 space, and you'd like to move this camera from, say, you want to move its target from T1 to T2. And how do you do this? Now the motion is assumed to be in 3 space, so there's a vector from T1 to T2, and T2 is where you'd like your target to be, and T1 is where your target is right now. So how do you interpolate between these 2 points, T1 and T2? The same thing applies to its camera, C1. You could also have a C2 where you'd like to move the camera to a new position. So the easiest way to do this is to use linear interpolation, which is if you assume where you are right now, or where your target is right now, is T of T as a vector. At my next interval, I would like to add a little of the distance between T2 from T1 to it, and you use time to kind of iterate through this. And that's an interpolation. And it's effectively just keep moving at little steps until it gets there. And that works very well. The thing is, it's very rigid. It's kind of like bam, 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 and then there you are. Not the most amazing thing ever, but it works. But there's better ways to do it. For a situation where you're in space, we wanted something a bit more dynamic. And the answer to that is an exponential filter, or a first order filter, or a P controller. They're all kind of the same thing. It ends up everywhere. You see it all over the place. It's also known as an exponential weighted moving average by the financy numbers guys. Now the secret here is it's as complicated as doing linear interpolation. Instead of tracking where you started and where you want to go, so instead of tracking T2 and T1, you completely forget about T1. And you only keep track of where you are and where you want to go, i.e. T and T2. And from that point on, all you do is you calculate the error. Now the error is equal to T2, which is my target, minus T, which is where I am right now. And that's my error. There's no T1 involved here. And for my update, I just take my error, multiply it by some coefficient, which is between 0 and 2, and roughly about normally 0.9, and multiply that by the change in time, delta t. So what you can see from the graph is, technically this filter is actually asymptotic, and it never actually gets to where you specify the target is, but it gets really, really, really close. And the nice thing about it is, every time you get a little closer, the error gets a little smaller, and you move a little slower. So as you're sort of approaching your destination, T2, you get the smooth kind of fly-in effect, which is really sweet. So how do you do this in code? Let's say you were looking at the example above, where you want to first order filter the camera's position and its target, and they're both vector 3s. All you need to do is you need to provide coefficients for the rate, the target k and camera k values, and keep track of the current location. Obviously, I'm sure you're doing this already. And keep track of the final location, kind of where you want to go. And this is target final and camera final. And the other thing you need to know is how much time elapsed since the last update. And that's generally in seconds, or delta TS. At every update, all you do is you calculate your error. In the case of the target, it's target final minus target current. And then you update the target current, which is where it is right now, plus delta TS times its coefficient times the error for the target. And you just keep doing this every update. You just let it do its thing. It'll never diverge, it'll never run away. It'll just maintain a fluid flow between where it is right now and where it should end up in the end at some point. I mean, the proof is in the pudding, so go have a look at the menu system and drop us a mail if you like it, you don't like it, what you'd like to see it do, how you'd like the motion to work, or why it does, or whether it does or doesn't even, or just to say hi. I mean, drop us a mail, Sam at Ad Courses or Daniel at Ad Courses, and we love talking code. It's very interesting. We're as curious about what you think about this as you are about how it works. So yeah, fantastic. There are code samples on the website. There are also links to places where you can look up more about the math. Try it out, so let us know. Any questions, just pop us a mail. So now you've got this very visually stimulating scene. How do you throw a menu on top of it? This became quite a headache for us because we don't want to throw more graphics at this, because then you kind of detract from this panorama in the background. So what do you do about a menu? How do you actually show information and navigate in this?
One of the suggestions was an older DOS-style type interface to the satellite.
So the idea was to overlay a very old school DOS-style interface with this highly visual background, as though you were controlling an actual satellite, because they would minimize the overlay information. It costs money and processing power to put this on, so why waste? So you have this very 1980s contradictory overlay on top of a smooth panoramic background. And that was our idea for the menu system. So the developers now were really happy with this brand new menu system. It's way, way, way cooler than what we had before. We were going to run off now and go build some awesome weapons so that you can shoot some more stuff up. But the content guys weren't quite there yet.
Something was missing.
That's what your girlfriend said.
To us, the scene was visually appealing, but it still looked empty. It still didn't have that effect we were looking for from a space scene, and we thought it needed a bit of volume. So I made the suggestion that we add crepuscular rays to the sun. It would be totally easy and really add that visual effect that we were looking for. I mean, Crytek did it after all. How hard can it be?
So we have no idea what crepuscular rays are. And after a quick Google, we find out what kind of effect he's looking for. As far as it's called God rays. And this is where there's a light source that generates a volume light that actually it's occluded by objects. And these God rays or crepuscular rays are something that's very nice, very neat, very new, and very difficult to produce. But luckily Dan says, I've got an awesome piece of sample code that you can just copy and paste for a shader and it'll give you these God rays.
So I provided the link to the sample code for all programmers to look at.
The whole sample, anyway, was about 5 lines of code, and it was the left nut on the head gasket of this huge Ferrari engine we need to produce this crepuscular rays. And I'm exaggerating slightly, of course, but there was a lot of stuff missing from this. But the effect is actually truly amazing and would look great in this scenario. So we'd have to produce a lot of educated guesswork to get the rest of the bits and pieces working. So you've got the space scene, but all it looks is flat. How do you give it a bit of body? And the answer to that is God rays or crepuscular rays. And the first question a lot of people ask is, what are crepuscular rays? So here's what crepuscular rays should look like. You can see that the light almost has body as it's shining through the trees. And this is the kind of effect that you'd like in a space scene, or that Daniel was aiming for in the space scene, to give it, as the light kind of moved around or shone through the satellite and around the planet, you'd see this light in its stenciled form. The idea is that when light passes through a fluid like air, it reflects off of the particles, and when these reflections are kind of superimposed against the darker object like a cloud or a tree, it looks as though the light is casting rays. So obviously, if you wanted to be true to form, you could actually do a bit of ray tracing, but yeah.
Ain't nobody got time for that.
So how do you cheat it, huh? And that's the important question. In chapter 13 of the GPU Gems 3, Kenny Mitchell provided the most awesome cheat codes for this. It uses no ray tracing. It's totally 100% post-production, as in you can write it in a pixel shader. Yes, 100% completely 2D. And it really just involves smudging the light. So, how is this done?
Step 1. Render a right background. And then render the objects you want to occlude against this white background. Draw them as silhouette.
Step 2. Take this background, project the location of the sun onto it, and draw the sun over the white area that isn't occluded. Step 3. Start smudging. For every pixel on the image, generate a 2D vector from that pixel to the center of the light source. Then take a fixed set of samples along that vector. Basically what you're doing is calculating an average, but the closer you are to your original pixel, the more influence the value has, and as you approach the light source, you start tapering off that amount of influence. So, this pixel samples a set of points towards the light source. Every time it samples, it lowers the influence of that sample, and it sets the current pixel to that averaged color. Lastly, take your smudgerific image and just superimpose it on top of your original scene. Bam! Now what's really cool is, just by swapping out the texture, you can get a whole different feel in your environment. And in this scene, we've now taken the predominantly red sun, and we changed it out for a yellow one. And the whole scene feels lighter and sharper, just by changing out this one little texture. At the moment, if you play the game, download, you'll see that we're using a blue sun, just because we thought, hey, this would be really sweet. But a quick caveat on artifacts. Not the cool Tomb Raider type ones, but the nasty little horrible imagey ones. When you do this, you're going to probably have to choose a number for that number of samples in the smudging. Realistically, it's going to probably be between 15 and 40 samples. Any more than that, and expect a frame rate of like 2 frames an hour. Any less than that, and your effect is completely lost. Well, that's kind of what we found anyway. Now, with that number of samples, you're probably going to get artifacts. And that ends up as these lines around your rays. The easiest way to get rid of this is just throw a Gaussian filter at it. cleans up most of the effect. So after you've done smudging, just put in a Gaussian filter pass before you superimpose it on top of the original image. Problem solved, and there we go, Crepuscular rays. This is kind of an overview, but it's highly recommended to look at the end of this article and the accompanying links. There are tons of code sample on how to do this. You can pretty much reassemble the effect without writing a line by yourself. Very, very cool effect. Definitely worth the hassle. On a closing note, am I the only one that looks at this and goes, dude, can you imagine the asteroids type game you could write with this?
Committing to a new project again, Sam. So here's a look of the new menu system and how it runs from start to end. But I should explain a few things here. The reasons we chose to stop at certain points in the scene, for instance, was to give the player a sense of progression towards the gameplay. So you'll notice as you get closer to playing the game, you're getting closer to the satellite, and eventually you're looking almost down at the planet, ready to get into the game and play. Thanks for watching, guys, and over to you, Sam.
We really appreciate your time and that you watched this movie. So please download Zeta Stereo if you get a chance, and let us know what you think. If you're interested at all in talking code or general game development, just catch us on Facebook and Steam. We'd really love to hear from you. So this is Gears signing out, and have an awesome day.
Hoorah!